Hello dear students. This is assessment problem 4.2 of the book Electric Circuits by Nilsson. Today we are again going to discuss the node voltage method, in which we have to find out the value of this V, which is developed between this and this point in this circuit. In node voltage method we have several steps, and the first of those steps is to identify the number of nodes which are available in this circuit. So how many nodes do we have here in this circuit? So identifying them, the first node here is this one. This is, let us call it node 1. The second node here we have is this one. This is node number 2, and the third node here, again this one, where all the branches are connected together. This is node number 3. In first step, when we have identified all the nodes available in this circuit, we have to make the equivalent circuit. So in order to make the equivalent circuit here, let me make the equivalent circuit. So okay, this one and this one, these are our two nodes. So let me call the voltage at node 1 as V1, the voltage at node 2 as V2. This is the resistor of value 2 ohm. This is 6 ohm, and this is 2 ohm. Okay, so at node 1 we have some branches. So the first branch here is this one. This is the branch of resistor 1 ohm. Similarly, at the other branch we have a source which is of current 4.5 amps. Okay, at node 2 we again have two branches. The first branch here is this one, which is of 12 ohm, and the second branch here again has two components here. The first one is the resistance of value 4 ohm, and then the voltage source of value 30 volts. Okay, so this is our equivalent circuit, where we have identified all the three nodes. So this is node number 3. So as I told you earlier, that we have to select one of these nodes as a reference node. So for selection criteria, as the selection criteria of a node is more commonly used, is to identify that node as a reference node in which most of the branches are connected. So here node 3 is the node which possesses those characteristics. So selecting it as a reference node and calling it the reference node. So we have this circuit. So now applying KCL at each node of this circuit, let me call this one V1, and we can see that here we have some currents. The first one is the I1, this current is the I2, and this one is the third current, which is I3, which are flowing away from the node 1. So according to the KCL, the sum of all the voltages which are flowing away from a node is equal to 0. So applying KCL at V1 at node 1, okay, for V1 applying KCL, Kirchhoff's voltage law. So here we will have I1 plus I2 plus I3, this is equal to 0. Okay, we know that the value of I1 here is 4.5, but the direction of this current is opposite as that of the current which we have supposed. So the current of this is current is of minus 4.5. Similarly, the value of I2 is the potential difference divided by the resistance. And how did we find out? We have found out it by using the Kirchhoff's voltage law or KVL. So here applying KVL at this branch, we will see that the value here V1 minus 0 divided by 1. Similarly, the current I3 is again the potential difference divided by the resistance. So these two are connected in series. So adding them together, we will get 8. So here V1 minus V2 divided by 8, this is equal to 0. Okay, so let me simplify this one. In simplifying this one, moving this minus 4.5 to the other side of this equation, we will get V1 plus V1 minus V2 divided by 8 equal to 4.5. Similarly, taking the LCM here, LCM is 8. So 8 V1 plus V1 minus V2, this is equal to 4.5. Adding these two together and moving this 8 to the other side, we will have 9V1 minus V2 is equal to 4.5 multiplied by 8. So ultimately 4.5 multiplied by 8 is 36. So we will have 9V1 minus V2 is equal to the 36. Let me call it equation A. So now we have one equation for node 1, and this equation is in terms of V1 and V2. Let me move towards the second node here, which is V2, and let me represent it with the green color. So here again we have three currents which are moving away from this node, which are, let me call these currents as I4. The second current here is I5, and the third one here is I6. Okay, so now we have three currents here, and at V2 again applying the KCL, the sum of all the currents which are moving away from node 2 is equal to 0. The value of I4 is again applying the KVL here, we will get V2 minus V1 divided by 8, potential difference divided by the resistance. I5 is V2 minus 0 divided by the 12. And similarly here at this branch, the application of KVL at this branch, we will get, this is voltage rise, this is voltage drop, because current is entering from the positive terminal and leaving from the negative terminal. So this is the voltage drop. So here the application of KVL will give us V2 minus 30 and minus 0 whole divided by the resistance which is connected in between them, that is 4. So this is equal to 0. Okay, so this one again, V2 minus V1 divided by 8 plus V2 divided by 12 plus V2 divided by 4 minus 30 divided by 4, and this is equal to 0. Simplifying it, V2 minus V1 divided by 8 plus V2 divided by 12 plus V2 divided by 4, and this is equal to 7.5. moving, this will be minus 7.5, moving it to the other side, we will get 7.5. okay, so now again taking the LCM here, let me do more calculations here. Taking the LCM here, we will have the LCM equal to 24. okay, so this will be equal to 3V2 minus 3V1, similarly plus 2v2 plus, and this will be equal to 6v2 equal to 7.5. okay, so now this 3v2 plus 2v2 is 5v2 plus 6v2 11v2, so we will have minus 3v1 plus 6 plus 5 is 11v2 divided by the 24 multiplied by 7 point, sorry, this is not the multiplication, this is the equal sign, so 7.5. so now simplifying it, 24 multiplied by 7.5 is equal to 180. okay, so minus 3v1 plus 11v2 equal to 7.5, moving this 24 to the other side and multiplying it with this 7.5, we will get 180. so this is equation B. So now we have two equations, sorry, now we have two equations, equation A and equation B. In order to calculate the values of v1 and v2, for finding out the value of v, we have to solve this system of linear equations and find out the value of v1 and v2. We can use many methods, but here I am going to apply the simpler one, which is our method here. So here applying or multiplying both sides of our equation with some number and then moving forward. So let me go down. So now we have, as we have these two equations, the first one is 9v1 minus v2 is equal to 36 and minus 3v1 plus 11v2 is equal to 180. okay, so this is A, this is B. So let me do the operation just by multiplying 11 with equation number A and then adding with equation B. What I will get here, multiplying 11 with A, I will get 99 v1 minus 11 v2 equal to 36 multiplied by 11 is equal to 396. okay, and then adding it with minus 3v1 plus 11v2 equal to 180. adding them together, these two will cancel out. Here we will get 96v1 equal to 180 plus 396 is equal to 576. okay, so ultimately v1 will be equal to 576 divided by the 96, and this is equal to 6 volts. okay, so the value of v1 is 6 volt. We have found out the value of v1, which is 6 volt. In order to find the value of v2, let us pick it and place it or put it in equation B. Let me put it in equation B. So in equation B, minus 3 multiplied by 6 plus 11 v2 is equal to 180. so minus 18 plus 11 v2, this is equal to 180. moving this minus 18 to the other side, we will get 11 v2 is equal to 180 plus 18. so 11 v2 is equal to 198, or the value of v2, dividing both sides by 11, we will get the 11 volts. The value of v2 is this 18 volts. okay, so we have found out both of these values. These are all values which we have found out. So now in order to find the value of this voltage V, we can see that the voltage is developed here, and the voltage here is the voltage at this point minus the voltage which is dropped across this 2 ohm resistor. So in order to find the voltage drop across this 2 ohm resistor, we have to find out the value of the current which is flowing across this one. So the value of this current is, let me call it I1. So the value of I1 is equal to the V2 minus V1 divided by 8. Okay, so the value of V2 is, as we have found out, it was 18, and the value of V1 was 6 divided by 8. So it will be equal to 18 minus 6 is 12 divided by 8, and this is equal to the 1.5 amperes. Okay, so the value here is 1.5 amperes. Similarly, the voltage drop at this 2 ohm resistor, let me call it this is plus, this is minus, let me call it V0. So the value V0 here is equal to the 2 multiplied by I1. So 2 multiplied by 1.5, this is equal to the 3. Yes, this is equal to 3 volts. Okay, so V0 is this 3 volt. So in order to find the value here, which is this one at this point, this is equal to this voltage minus this voltage. Okay, so the V, small v here, this is equal to the V2 minus V0. Okay, so let me go down. Okay, so this small v is equal to the V2 minus V0. The value of V2 was 18, while the value of V0 is 3. So let me write it down. So this is now 15 volts. So the answer of it is 15 volts. So this is the required quantity which I had to find out, and that's it. This is the question, and we can find out all the other quantities which we are asked to find. So this is the question, and I hope you have understood it. I will bring other questions for your practice in our next video. Thank you so much.